So where the last one they had the plus sign, this one has the subtract, so I have x squared subtract 16 on the bottom equals 0. This one, since it's subtract here, I can make this one equal to 0. So this is the difference of two squares, so when I go to solve this one, we have x subtract 4 times x plus 4 equals 0. Then we'd solve for both binomials to get x equals 4 and x equals -4. The big thing on this one is typing it into MyMathLab. So when we type this one into MyMathLab, they want it in interval notation. So we have negative infinity to -4, unioned with -4 to 4, unioned with 4 to positive infinity. That's the trick one on this one, and I'm sure I'll get a lot of emails over that one. Okay, so on number 5, this square root of 2x subtract 10, if you remember from 1.3, we can't have a negative under the square root, otherwise that's an imaginary number. We don't use imaginary numbers in functions. They have to be all real numbers. So when we go to solve this one, we want it to be greater than a negative, but it can be equal to 0 because the square root of 0 would just be 0. So when we go to work this one out, we have 2x subtract 10 is greater than or equal to 0. And then we'd solve it for x. So add 10, 2x is greater than or equal to 10, divide by 2, x is greater than or equal to 5, and then we'd write that in interval notation. Here's the input-output table they gave us. And I guess I use my family now that I'm looking at this. So the domain is always the input, and the range is the output. So our domain why did I put so many of them? And me. Okay. And the range would be and then on this one, when we're checking input-output tables for functions, we just see if any of these have 2 lines that come off of them. Since there's none that do have 2 lines, this one would be a function, so yes, because for every input there's 1 output.